Hi everyone, so we're looking at 5.2 linear growth. In this section we'll take a look at slopes, y-intercepts, and creating functions where you have to look at restrictions on the domain. Now this first problem, find the slope and y-intercept of the following linear equation. Express the y-intercept as an ordered pair. So if you look over here, I've got the whole slope-intercept formula, y equals mx plus b, might look familiar, where m is the slope and b represents the y-coordinate of the y-intercept, and you write the y-intercept as 0, comma b. If you just say that b equals the y-intercept, that's incorrect. Just making sure y'all know that. Hopefully you already do. So I'm going to use this idea now and figure this problem out. So our slope right there, it's going to be 1/5, and our y-intercept, it's pretty easy. All you have to do is look at this last number. As long as you've solved for y, just look at the last number. So it's going to be 0, comma -5, and make sure to keep your parentheses. Looking at the next problem here, Tom is reading a book. He reads 84 pages per hour. We're going to write a function that represents the number of pages he reads, and we'll be sure to indicate any domain restrictions. So we're going to make this guy f of x, because that's our variable we're going to use, and it's 84 pages per hour. So that's going to be 84 pages per hour. We don't know how many hours we're talking about, so that's what x is over here. And over here we're going to say it's for x being, if you can get it to pick, being greater than 0. So because you don't read a negative pages, right? So that should be the answer. If you don't believe me, there's your proof. Let's move on to the next one. The water depth of a pond is initially 30 inches and decreases at a rate of 0.5 inches per day through evaporation. What's the depth of the pond after 20 days? Let me get this one set up for you, and then we'll take a look at it. All right, I've got this problem set up. So it's a function. What we're going to do is say f of x equals 0.5x, right? It's 0.5, meaning your inches per day, times the x, where x represents the number of days. So say if it's 10 days, then it'd be 0.5 times 10, which would be 5. So we were looking at 5 inches over the span of 10 days. Now we need to add to that our initial depth of the pond, which is 30 inches. And that's your function that you're looking at right here. So what's the depth after 20 days? Well, just plug in a 20 for your x. So in this case, 20 days, oh, you know what? I stand corrected. Guess what we forgot? It's decreasing. We need a negative here, don't we? Haha, I would have gotten that one wrong. Well, I'm glad we caught it. So it's decreasing at a rate of 0.5 inches per day through evaporation. So after 20 days, we're going to multiply that by negative 0.5, and then we'll add that to 30. I'll leave that one to you to figure out, but that should give you your answer, no problem. Let's take a look at the next one. An assignment is worth 150 points. For each day the assignment is late, the professor deducts 5 points from the assignment grade. We're going to write a linear function that represents the maximum number of points the assignment may receive at any given time, assuming it was turned in after it was due. Hang on just a second. I need to get this one set up. All right, I've got this problem set up now. So we're looking at f of x, right? That's our function we're working with. Now, you can look at this a couple different ways. You can write your y-coordinate of the y-intercept first, or you can write the slope part first. Personally, I like writing the slope part first, but the way I've got this problem set up, I actually got the y-intercept for the y-coordinate of the y-intercept part first. So let's go ahead and set it up that way. So we're looking at 150 points is how much this thing's worth initially, right? Now, we're deducting 5 points every day this assignment is late, so it's going to go down. So we'll go minus 5 times x, and that should be our function that we're going to work with. Now, the domain's going to be a little tricky. That's actually why I had to pause. I had to get this set up so you could see what's going on here. So we will say that the lowest it's going to be would be 0. And by 0, we mean on day 0, no points are getting deducted. So that's going to be our minimum point. And then in the middle, we're going to have x. And the maximum, That's what we need to figure out here, what our maximum, how many days are going to go before you can't lose any more points, because it's 5 points every day, so over a certain amount of time you're going to run out of points total, right? So if you want to look at this from an equation standpoint, here's what you do. F of x represents the total number of days transpired there. Or, excuse me, not the total number of days. It's the when you reach 0 points. So you let 0 equal f of x, and we're going to solve for x. So we'll add 5x to both sides, then divide by 5. We're looking at 30. So our domain then is going to be, let me move this over. It's going to be between 0 days, at which time there are no deductions, and 30 days. That's when you're looking at your maximum deductions. So over here we're looking at 30. Let's see if we got this one right. Oh yeah. All right, let's move on to the next one. To find the slope and the y-intercept of this guy, what I would do is solve this thing for y, and that'll help us figure out what the slope and y-intercept are going to be. Let me see if I can get that set up for you real quick. All right, so I just retyped the equation here in Word so that we can see what's happening. What I would do is subtract the 10x to the other side, first of all. So that puts us at 8y equaling a negative 10x. And then we'll add to that 11. And then we'll divide by 8. So y is going to equal negative 10 over 8 with an x, and then add to that 11 over 8. So then what we'll do is take that fraction of negative 10/8. They're both even, so I'm going to divide both of them by 2. So negative 10 divided by 2 is 5. 8 divided by 2 is 4. So that's what this guy's going to reduce to. And then that other fraction, that 11/8, that will not reduce at all. So that's basically what we're after here. I just solved this equation for y. And what that does is it gives us our m value, which is our slope, of a negative 5/4. So right here you would type in negative 5/4, and then down here you would type in 0, positive 11/8. So if you don't believe me, I'll just go ahead and prove it to you. And if I get it wrong, that'll be embarrassing, but I'll get over it somehow. I think you can use this button if you want, but I'm just going to use parentheses here. 0, and then 11/8. It's a fraction, so let's use our little fraction tool here. 11 over 8. That should give us our answer. Yep. Let's move on to the next one. Let's see. We're going to assume that the cost of the taxi is $2 per ride and $1.70 per mile. What function represents your total cab fare? Be sure to indicate any domain restrictions. This one's going to be a little tricky because of this whole per ride and per mile. The reason I say that is because when you have the word per, a lot of times that kind of gives a clue as to what the value is going to be for the slope. So, but I've got two pers in here. I've got $2 per ride right here, and I got $1.70 per mile. So which one's it going to be? Well, it's going to be the $1.70, and I'll explain why. So first, f of x equals. We're talking about each ride. So a cab fare, it's a one ride type gig, so you can go 2. That's going to be the y coordinate of your y-intercept right there, because you're going to be paying $2 no matter what on the ride. So what's a variable here is the $1.70. Now it is an additional cost, so we'll go plus 1.7, and we're going to multiply that by x because we don't know how many miles we're talking about. It could be 1, it could be 30 or more, who knows. And then we need our domain restrictions for x, and then it's going to be greater than or equal to 0. And that should do it for that problem. Hopefully that helps. Let's move on to the next one. Find the slope and y-intercept of the following linear equation. Express the y-intercept as an ordered pair. Personally, I think this one's easy, but it might not be as easy as you might think, because you're like, well, wait a minute, where's the b? Well, that's what's going to make this thing easy. It's one of those so easy that it's hard problem. If you don't see one, Assume the origin. 0, comma 0. Boom. Oh, it didn't like it. See? I rest my case. Sometimes it's so easy that it's hard. Why did it not like that? Express the y-intercept is an ordered pair. Give me just a second so I don't waste your time on this video. Well, this is a little bit of a head scratcher, but I think I might have figured it out. For whatever reason, I think it's making me use the parentheses thing here in the little keypad. Let's see if that's it. Wow, that was weird. I'm going to be contacting the publisher about this one because I should have been able to use the parentheses on my keyboard with this one, but it is what it is. Let's move on. You could purchase a car for $16,000 or you can lease it for $350 per month with a down payment of $600. How long can you lease a car before the amount of the lease is more than the cost of the car? Well, this should be interesting. Let's take a look. All right, I got this one set up. So it's going to be another function. But it's like what goes where? Well, we're talking about a lease, first of all, that's going to be $350 per month, and you're doing a down payment of $600. So what's going to be the B, if you use the formula, slope-intercept formula, y equals mx plus b, what's going to be the b, what's going to be the m? In other words, what's the slope, what's the y-coordinate of the y-intercept? Now, the y-coordinate of the y-intercept, it's going to be this value, your down payment of $600. Usually, that value is, the b part is going to be your starting point, like what your starting point, like the down payment or something like that, or your initial value that you're talking about. And then our m is going to be $350, and x is going to be how many months are transpiring. So our formula is going to look like this. F of x equals 600 plus 350x. That's our function for the lease. And what we're going to do to find out when the amount of the lease will be more than the cost of the car, well, we're just going to substitute in 16,700 right here for f of x. And then once you do that, just solve for x and you'll have your answer. Just like that. I'm going to leave that one for you to do, but that should get you where you need to be. Find the slope and y-intercept of the following linear function equation in this case. That one should be straightforward. I'll let you guys deal with that. And then finally, Kathleen makes 144 cupcakes each week. Of these, she sells 25 each week and gives away the rest. We're going to write a linear function that represents the number of cupcakes Kathleen has given away over time. This one, if I'm not mistaken, is a little bit tricky because it's like, what's B and what's M? A lot of people will say, oh, the 25 will be the M, and the 144 would be the B value. Not so in this case, I don't think. Let's find out. So we're talking f of x, and the reason I say not so is look at our rates here. We're talking 144 cupcakes each week, and over here it's 25 cupcakes each week. They're the same rate. So what we're going to do is she's giving away the rest, so we need to subtract basically. What we're going to do is we're going to take 144, well, I'll set it up over here. Let me erase this. The actual function would be something like this. F of x equals 144x minus, what was it? Oh, 25. Minus 25x. All right, now if you simplify that, you take 144 minus 25, which is 119x. And that, my friends, is what we would put right here. Right? So we just have a slope. We don't have that y-intercept value. We're going to assume that's 0. And that's going to be our linear function that talks about what represents the number of cupcakes that she's given away over time. It depends on the number of weeks we're talking about. And of course, for our domain, our x has to be greater than, and you notice I had a little trouble picking that greater than. You just kind of have to toggle with it a little bit. Greater than 0, and that'll give it to you. And that should do it for this section. All right. And